Hello everyone, what are the Martian seasons like? Let's find out. Earth's rhythm of spring, summer, autumn, and winter provides a familiar cadence to life on our planet. But what about Mars? The red planet also experiences seasons, sculpted by its own unique characteristics and place within the solar system. Let's dive into the fascinating world of Martian seasons and explore the implications for future explorers hoping to set foot on this distant world. Like Earth, Mars has seasons because its axis is tilted. However, Mars has a more pronounced axial tilt, about 25 degrees compared to Earth's 23.5 degrees. This greater tilt leads to more extreme differences between Martian seasons. Additionally, Mars has a significantly longer year than Earth. A Martian year lasts about 687 Earth days, almost twice as long as ours. With a longer year, each Martian season is much more extended compared to our familiar cycle on Earth. Spring on Mars is a time of dramatic transition and a stark reminder that the red planet operates on its own cosmic schedule. In the northern hemisphere, the vast ice caps at the pole, composed primarily of water ice and frozen carbon dioxide, start to recede as temperatures gradually increase. This sublimation process releases carbon dioxide into the atmosphere, creating strong winds and sometimes fueling planet-encircling dust storms. With longer days and a slow, gradual increase in temperature, the Martian spring begins to shake off the long winter. While Martian temperatures remain far below what we consider comfortable on Earth, summer in Mars' northern hemisphere is when the planet is closest to the Sun in its elliptical orbit. Due to the planet's greater distance from the Sun compared to Earth, even summer on Mars is remarkably cold by our standards. At the equator, you might encounter daytime temperatures somewhat similar to a chilly Earth day. However, nights plummet to well below freezing, and temperatures become far harsher as you approach the polar regions. In the southern hemisphere, it's the opposite. Here you'll find the coldest winter of the Martian year, marked by extreme temperatures as Mars swings away from the Sun. The Martian autumn sees continuous change across the planet. The northern polar ice cap shrinks, while ice accumulation intensifies around the southern pole, fueled by water and carbon dioxide freezing out of the atmosphere. It's a period of dramatic atmospheric activity. Potentially vast, global-scale dust storms can occur, driven by the interplay of warming temperatures and increasing winds. As Martian autumn progresses, the days start to shorten, and temperatures steadily drop in preparation for the coming winter. Winter in the northern hemisphere is relatively short and mild compared to the extreme chill of its southern counterpart. This is because Mars is farthest from the Sun in its elliptical orbit during the southern hemisphere's winter. At the southern pole, during its long, dark winter, the ice caps expand significantly, and temperatures can plunge to incredibly low levels. Conditions are so cold that carbon dioxide in the atmosphere freezes and can fall as snow. Unlike Earth, where the names spring, summer, autumn, and winter carry familiar associations, scientists studying Martian seasons often rely on a slightly different system to mark the flow of time on the red planet. They pay close attention to the changing dates of the solstices and equinoxes, which provide reference points in a Martian year, somewhat analogous to those we have on Earth. Additionally, they use the concept of solar longitude, LS. On Mars, LS0 marks the vernal equinox in the northern hemisphere, the beginning of spring. LS90 marks the summer solstice in the north, LS180 marks the autumnal equinox in the north, and LS270 the winter solstice. These more technical terms are vital for tracking the seasonal variations that directly impact planning for future missions. Understanding Martian seasons isn't just about satisfying scientific curiosity. It has profound implications for future Mars missions. The timing of exploration missions will need to carefully consider these unique seasonal patterns. Missions to the ice caps aimed at potential water extraction would need to take place during a time when the ice is likely to be receding, enhancing accessibility. Future explorers on Mars will need to be prepared for the possibility of vast dust storms, particularly during the Martian spring and autumn, which could severely impact both equipment and operations. And those hoping to use solar power will need to meticulously plan for the significant variations in solar energy throughout the long Martian year and across different locations on the planet. The exploration of Martian seasons is still in its relatively early stages. With each mission, landers and rovers gather invaluable data about temperature fluctuations, wind patterns, and atmospheric changes across the Martian year. This growing body of knowledge will be indispensable as we plan for a future where humans walk among the red sands of another world, taking those first tentative steps in becoming an interplanetary species. The study of the Martian seasons is not only about understanding another world, it's a critical part of unlocking the secrets of survival within an alien and often unpredictable environment. Thank you for watching. Please follow for more related videos and see you later. Goodbye.